Okay, coil 1 has L1, okay, self-inductance 30 millihenry, and N1 number of turns, 150 turns. Coil 2 has self-inductance L2, 40 millihenry, and number of turns, N2, 250 turns. The mutual inductance is 4 millihenry. So at a particular instant, the current is 5 milliampere through coil 1, and this current changes at the rate of 4 ampere per second. Okay, determine the flux linkage in coil 1, flux linkage in coil 2, and induced EMF in coil 2. Okay, so here, as you notice, we have 2 coils. Okay, hold on a second. Okay, as you can see here, we have 2 coils. Alright, coil 1 and coil 2. So as I told you before, okay, when we do this electromagnetic induction, yeah, we want to determine whether is it self-inductance or mutual inductance. We always pay attention to how many coil, yeah, it involves. Okay, if you can see the question has only 1 coil, okay, 1 coil involved, then it's definitely only self-inductance happen. Yeah, self-inductance. Okay, if you have 2 coils, okay, 2 coils, maybe it's a solenoid plus 1 coil. Yeah, for example, just 1 solenoid with 1 coil. Yeah, 2 coils. Then the question it might ask is either self-inductance, or maybe mutual inductance. Okay, so if only 1 coil, that means the question can ask is only self-inductance. If you have 2 coils, then that means it can ask either self-inductance or mutual inductance. All right. So that's the tips lah. Yeah, that's the tips. Mutual inductance. Yeah. My writing. So sorry. So okay. So here we have 2 coils. It's better we write down the information below. Yeah, in 2 columns. So we have a more systematic way of gathering data. Okay, we have coil 1 and coil 2, and then we need to determine which one has the current, which one don't have the current. Okay, which coil induced EMF, which coil has the current. Okay, which coil has the current changing at certain rate. Okay, so all right, so okay. Okay, he write down all the information given. So we have the length 1 equal to 30 millihenry. We need to change this to SI unit, Henry. Okay, and then number of turns also 150 turns. And coil 2 self-inductance 40 millihenry. Okay, and then number of turns is 250 turns, right? So mutual inductance, okay, I give you the mutual inductance value, which is 4 millihenry. Yeah, you need to change to Henry later on. Okay, at a particular instant, the current is 5 milliampere through coil 1. So that means which coil has current? Coil 1 has current. Okay, so coil 1 got current. Okay, got current. This one has no current. Okay, so so what I can say is he provide this coil 1 provide the magnetic field or provide the magnetic flux for coil 2. Okay, and then this coil 2 induced, EMF2 is induced. Okay, EMF2 is induced through mutual induction. Okay, so why this EMF is induced in coil 2? through mutual induction because there is a change of current happen in coil 1. Understand? There's a change of current di1 over dt. There is a change of current because there is a current changes. Current changes in coil 1. I1 changes. Okay, because we got the current changes here. So the magnetic flux he provide to coil 2 also changes because got change of flux due to change of current in coil 1. That's why EMF is induced in coil 2 through mutual induction. Okay. Anyways, coil 1 also will produce self-induction. Okay. Coil 1 also will have EMF induced. Yeah, E1 will also be induced. But this one is through self-induction. Why? Okay, this one is using L. Yeah. Why coil 1 has EMF induced also? Because this is called self-induction. Because the current in the same coil, changes. Induce EMF in the same coil. This is called self-induction. However, if the current in coil 1 changes, in the induced EMF in neighboring coil, in other coil, that one is mutual induction. Understand? So okay, current changes happen where? Current changes happen in coil 1. Yeah, current changes happen in coil 1. Because current changes happen in coil 1, that's why I got induced EMF in coil 1 through self-induction. And also because of changes of current in coil 1, that's why also it induced EMF in coil 2 through mutual induction. That's why if we have two coils, we can discuss both. We can discuss self-induction, yeah, in the own coil. We can also discuss mutual induction in the neighboring coil. So if two coils, can ask both. Can ask self-induction, can ask mutual induction. But if only given the question only give one coil, then it's only self-induction. Understand? Okay, and the formula to do it is this formula. Yeah, in the notes. Okay, so self-induction and mutual induction, the formula are almost the same. Just L change to M. Okay, mutual induction have subscript. Okay, have subscript like 2, 2, 2, 1. And then 1, 2, 2 like that. But self-induction has no subscript because happen at own coil. This one happen at two coils. Okay, so this one got subscript, this one no subscript. Okay, and then the formula for L and M is almost the same also. Just this one is n square. It's like n times n. This one is n1 times n2. N1 times n2 because got two coils. Understand? Okay, so we're going to use this formula to solve these questions. Okay, so right now, okay, so I have all the information already. Okay, I still haven't put in this value. This current 5 milliampere is through coil 1. So this is I1. Okay, put that as I1. Okay, coil 1 got current, so that's I1. Particular instant, yes, 5 milliampere there. Okay, and then this current changes at the rate of 4 ampere per second, so that is a di1 over dt. di1 over dt. Okay, di1 over dt, which is 4 ampere per second. 4 ampere per second. Okay, so that's it. Now I want to find the flux linkage in coil 1. Okay, you have the word linkage. Linkage. Yeah, this one also linkage. That means this one is for capital phi, not the small phi. It's capital phi. This one is phi 1. Question B is phi 2. Phi 2. And then induced EMF in coil 2. That means E2 lah. Yeah, we want to find EMF induced in coil 2. Okay, so let's do it. Yeah, let's do it. So let's do the question A first. Flux linkage in coil 1. So how are you going to do that? Okay, flux linkage in coil 1. Flux linkage in coil 1. So can we find flux linkage in coil 1? Okay, I can if flux linkage in coil 1, I just use the self-induction formula. This one, n phi equal to Li. This one, okay, n phi equal to Li. This one, this formula. All right, this formula. Okay, flux linkage. So you just use flux linkage n phi flux phi 1 equal to Li1. This one is L1 I1, okay, on coil, because I already have L and I, isn't it? And then the capital phi is actually n phi, yeah. Capital phi is actually n phi. Yeah. So flux linkage means it has many turns lah. Yes, n turns. Okay. All these have n turns. Flux linkage means you have n. Okay. So that means this n phi become the capital phi, which is what we want to find. Okay. So be careful. If the small phi is just for flux, means it's only one turn. Only one turn. If this one is called flux linkage. Flux linkage means you have many turns. You have n turns. Okay. All right. Now let's do it. L1 is okay. So I have L1 already. L1 is 30 millihenry. 30 milli is exponent -3 Henry. And then current I1 is 5 milliampere. So milli is exponent -3, change to value. Okay, milli. So okay, so calculate. Let's calculate milli. 30 exponent -3 multiply by 5 exponent -3. So the answer is 1.5 exponent -4. Okay, verbal. 1.5 exponent -4. Okay, verbal. That's right. Okay, so what is that the answer? Yeah, 1.5 exponent -4 verbal. That's correct. Okay, that's correct. Okay, now let's look at B. Question B. Yeah, question B. Now I want to find flux linkage in coil 2. Remember, the flux linkage in coil 2 actually come from coil 1. Okay, coil 1 has the current. It provides magnetic flux for coil 2. Okay, so this one is mutual induction. So we look at mutual induction. We use we want to find flux linkage. You can use this formula. See that? You can use this formula n phi, which is n phi is n multiply small phi. You get capital phi, the flux linkage. Okay, so we're going to use this formula. Okay. Okay, let's do it. Okay, so we want to find flux linkage in coil 2 with N2 phi 2 equal to M, mutual induction, I1. Why? Okay, again, why is it coil 2 has the magnetic flux linkage? Why coil 2 has the magnetic flux linkage? Because this flux linkage comes from coil 1. It comes from coil 1. Coil 1 has the current. Okay, coil 1 has the current. Okay, so okay, I just want to write something here. Okay, excuse me. So this n phi equal to flux linkage coil 2, okay, which is M I1. All right. Okay, so this is the flux linkage in coil 2. Okay. Okay. is provided by coil 1. Is provided by coil 1 because coil 1 has current I1. Okay. Okay. Why coil 2 has a flux linkage? Because the flux linkage in coil 2 is actually provided by coil 1, because coil 1 has the current, okay, has the current I1. That's how you put it. Okay, Mi1 equal to N2 phi 2, N2 phi 2 equal to Mi1. All right. What I can say is coil 1 has the current, has the current. So coil 1 can produce flux linkage in the coil itself, its own coil. It also provide flux linkage for coil 2. Yeah, coil 1 provide, because coil 1 has the current I1. Yeah, coil 1 has the current I1. So it provide magnetic flux linkage for its own coil 1, and it also provide magnetic flux linkage for coil 2, the neighboring coil. Okay, that is what it means. Okay, I want to write something. This one is the flux linkage in coil 1 provided by coil, its own coil lah, coil 1 because it has current I1. Okay, so coil 1 has current I1. Coil 1 has current I1. It provide flux linkage for its own coil, and also provide flux linkage in coil 2. Okay. So let's do it. Let's find out the flux linkage in coil 2, which is equal to Mi1. Okay, so the mutual induction is 4 millihenry. Here given 4 millihenry. Okay, put in 4 millihenry. 4 milli is exponent -3. And then current I1 is 5 milliampere. 5 milliampere. 5 milliampere. Milli is -3 also. Milli is -3. Okay, so what's the answer? Let's calculate. 4 exponent -3 multiplied by 5 exponent -3, which is the answer is 2 exponent -5. 2 exponent -5 Weber. That's the unit for Weber. Weber is the unit for flux. Yeah. So is that answer correct? Yeah, that's correct. 2 exponent -5. -5. Oh, this is a wrong unit. Flux linkage, this one is wrong unit. Flux linkage unit is Weber, not Henry. Okay, wrong unit. This one is wrong. It should be Weber. Henry is the unit for the mutual induction or self-induction. Understand? So for flux is Weber, not Henry. Henry is for inductance, okay, self-inductance or mutual inductance. So it's Weber. Alright. So the answer is 2 exponent -5 Weber. Is the answer correct? That's correct. Yeah. So now lastly, what is the induced EMF in coil 2? So we want to find induced EMF in coil 2. Let's find out. So question C, what is the induced EMF in coil 2? Okay. So why EMF is induced in coil 2? Why EMF is induced in coil 2? Because EMF is induced in coil 2 through mutual induction, because coil 1 because the current is in coil 1, because coil 1 got because the current in coil 1 changes. There's a change of current in coil 1. So when the current in coil 1 changes, so the magnetic flux he provide to coil 2 also changes. This flux also changes. I can say this is magnetic flux for 2 lah. So when the current in coil 1 changes, so the magnetic flux in coil 2 also changes. The magnetic flux he provide to coil 2 changes. So because got magnetic flux changes in coil 2, that's why got induced EMF in coil 2. This is called mutual induction. So EMF is induced in coil 2 because there is a change of, okay, EMF is induced in coil 2 because there is a change of current happen in coil 1. Okay, so for this we use what formula? We have change of current in coil 1. I have di1 over dt. Okay, and then I have mutual induction, so I can use this formula. Okay, understand this one? This one, EMF is induced in coil 2 because there is a change of current happen in coil 1. Understand? Okay, so let's do it. Yeah, let's do it. EMF 2 is equal to, yeah, use this formula. Yeah, E2 equal to negative M di1 over dt. What does it mean by this one? Okay, I can say this is EMF induced in coil 2. Okay, E2 means EMF induced in coil 2 because there is change of current I1 in coil 1. This is called mutual induction process. Okay, EMF is induced in coil 2. EMF is induced in coil 2 because there is a change of current in coil 1. Because there is a change of current in coil 1, that's why it induces EMF in the neighboring coil 2. Induce EMF in neighboring coil 2. It also, because of the change of current in coil 1, it also has self-induction. Self-induction happen in its own coil, so it induces EMF in its own coil also. Yeah. Okay, that's self-induction. Mutual induction is when there is a change of current in coil 1, it induces EMF in coil 2. That's mutual induction. Okay, so all right, so let me find out induced EMF in coil 2. So I have all the values here. Negative E2 is negative M. What is the M value? M value is 4 millihenry. 4 millihenry. Millihenry change to Henry. Yeah. The negative value need to write. The negative value here in the formula you need to write. It's very important. Milli is exponent negative 3. Okay. And change of current in coil 1 is you say current changes at this rate 4 ampere per second, right? 4 ampere per second. So 4 ampere per second, that's right. di1 over dt, that's 4 ampere per second. So what is the E2? So E2 is, let's calculate, negative 4 exponent negative 3 multiplied by 4, which is negative 0.016 volt. Okay, the negative value you must write. Is a must. Okay, because in the formula you have negative value. In the formula has if formula has a negative, formula has negative sign, so this negative value is a must. Okay, it means back EMF. Opposed changes. It means opposed changes. It means Lenz's law. Yeah, Lenz's law. Okay. you must write lah. You must write this value, yeah. This means back EMF. Okay, so that's the answer. Is that the answer? 0.016 volt. That's correct. That's correct, yeah. Here don't have negative sign. Maybe just focus on magnitude. But I encourage you to write the negative sign, yeah, because in the formula has a negative sign. You shouldn't just neglect the negative sign, yeah. Shouldn't neglect the negative sign. It means a lot, yeah. It means about back EMF or post changes, yeah. Okay, so the answer is correct, yeah. It's 0.016 volt. Okay, that's the answer. Okay, so I hope you understand already. That's the answer for these questions. Okay, this formula is good, yeah. Remember this formula. You need to use this formula. So again, the mutual induction, just want to let you pay a little bit attention. EMF is induced in coil 2. EMF is induced in coil 2 because there's a change of magnetic flux. Change of magnetic flux happen in coil 2. Why there is a change of magnetic flux in coil 2? Because there is a change of current in coil 1. So just a little bit attention for you here. EMF is induced. Okay. EMF induced. Okay, EMF induced in coil 2. EMF induced in coil 2. EMF is induced in coil 2 because there is a change of flux in coil 2. Change of flux in coil 2. Why there is a change of flux in coil 2? Who provide the flux for coil 2? It's coil 1, because coil 1 has the current. Because why there is a change of flux in coil 2? Because change of current I1 in coil 1. Okay, so because change of current in coil 1, because change of current in coil 1, that's why got change of flux in coil 2. Change of flux in coil 2 divide 2 over dt. Change of flux in coil 2, and because there's change of flux in coil 2, that's why got induced EMF in coil 2. Okay, so there's a change of there's an induced EMF in coil 2. So okay, that's all for this question. I hope you understand, and thank you. Bye bye.